So welcome back to Communicating Computer Science. In Unit 3, I want to show you a few bits of motivation and learning theories that hopefully help you as a backdrop for developing your lessons. It's not that we will try to throw in these terms in our lessons. It's more, how do you design your lesson, knowing that some of these things just happen in most humans. And so you can try to adapt a little bit to how you present things. I think some of it is, you can replace a lot of this just with experience and common sense. But you may not have the experience, and it's sometimes just a shortcut to common sense. So why not make use of what people learned? So the goal for this unit is to give you the vocabulary if you, in your lesson, want to talk about some of these things. So there's just a few buzzwords that may help you find the right sources and maybe frame your ideas. And the practical side of things, applying it where it makes sense. Now, the pre-session task was to first go through this exercise of the VARC scores. I'll probably have to do this here again. So we had the visual aspects where it's interesting. I think I'm fairly high on visual, the way I filled it out. More of you are on the low scores here. That's interesting. And then hearing. Okay, oh, this is not sorted by numbers. Okay, I have to be careful. So somewhere in the middle is the peak. And read-write, that's a tricky one. I think this is really hard to judge because it depends quite a bit on what you read. And okay, the last one, running around. Many of you found that helpful. So this is all nice and might be useful sometimes as a framing. But the theory behind it, that you're one specific type and you should try to make your learning cater to the different types, just seems not to be reflected in any of the studies, seems not to be true. It might still be useful. The core message is try to be teaching on various levels, and that seems to be effective. So it's the lesson that comes out of these scores might actually go in the right direction. So in a way, it's harmless if you want. But the core assumption that you're a specific type isn't. So this is just a warning. There's stuff out there. This VARC scores, they still exist. People still there's still this website. Some people follow it. It's sometimes hard to say. They sound reasonable. So just as a warning, not because not everything that has a nice website is necessarily backed up by science. So be a bit critical in this. I think I said this already. So representing things in different ways is useful, just for different reasons. There's two bits I want to talk about. One is why do people do things, motivation theory, and specifically for learning things. And the other bit is what does learning itself mean? A little bit of a background for that. So motivation can be described in many different ways. A simple characterization is extrinsic versus intrinsic. I guess that's fairly clear to you. Now, extrinsic motivation is very popular because it's so much easier to create as a teacher. It's something you have under your control because it's about the environment and the assessments and goals and so on. And well, I know this from our primary school. It can be very effective, no doubt, and it can be fun. All sorts of gamification, I think, is effectively extrinsic motivation that sometimes spills over. If people start to buy into the games, it could become intrinsic motivation. The danger is it might become intrinsic motivation for the game, for the stars, and not for the part that's behind it. So as much fun as it can be to get just people moving, you have to be balancing this. And of course, you can also go, this is not something we promote these days, but it is effective, sadly. Intrinsic motivation comes from within, so it's very hard to instill from the outside, but you can try to set the environment right so that it can emerge. And again, some forms of positive reinforcement might trigger intrinsic motivation or might set the stage for it to grow. So it's hard to really pin this down, but I think it has to do with being interested in doing something and enjoying it. There's a natural curiosity that you see in almost all children, and sometimes school is very effective at destroying that to a certain age. Not with all kids, but with some, and there's lots of socioeconomic background that plays into this. But curiosity is something built into humans. So this is one of the cards you can play. You just have to dig it out under all the rubble. And other things, easier is if you can find something that is already a goal of the person, and you just tack on to that goal what you want to teach. Yeah, so the dilemma is clear. Intrinsic is what we want, extrinsic is what we can control. Now, one theory I mentioned, I think earlier in some units, where does this intrinsic motivation come from? This is one of the theories I found helpful because it at least breaks it down into two parts. So intrinsic motivation comes from is the product of two factors, the expectancy and the value. So how valuable do you perceive achieving whatever it is that you're supposed to do? And do I have at least a reasonable expectation to succeed in this? And you can imagine if one of the two is at 0, then the whole thing will not work. I'll leave it with just these two ideas. Just keep this in mind that you want both. It's fairly clear if you think about it. But if you design tasks, the challenge can be this second bit. The first bit you often just needs framing, but might be framing for different groups. So try to find something that is versatile. The second bit also needs adapting to where kids are in their prior knowledge. Obviously, that differs. So that's the other two buzzwords: low floor, high ceiling. Try to find tasks where you can get started easily without much background, but where there's lots of room to grow if you're more advanced and want to dig deeper. It's often possible, but needs a bit of thought how to put that into a lesson that works for everyone. Here's a module that was used in teacher training for us when I was a postdoc in Waterloo. I found this is an online thing where you can just click through. I found this quite nice in terms of making these theories more concrete with lots of examples from higher education. So it's not for teaching kids specifically, but a lot of these things are essentially the same. At least from the age group that we're looking at, it's not so different. So how can we try to instill value? That's a tough one, and because you're trying to do this with very different human beings, so you have to have a portfolio of different approaches. You can try to get to where people are in their lives, so it's try to solve some real problem that they might have, or at least that they can imagine to have. Or pick up some device or something that they use and challenge them to think about, do they actually know what's going on inside, or do they just view this as a magic block? Maybe you can break that open a bit. You can try to go over the people that invented something. It can be quite interesting because there's often memorable stories. This is more about how human memory works. We often are much better at memorizing a narrative, a cohesive story step by step where one thing follows from the other. If you have an interesting story to tell about the history of a topic, that might be enough to motivate people to care about it, for some people at least. The last one is often easy to start with, but then going back to a small topic is tough. If you want to play the "it's good for society" card, you have to at some point bring it back to what can we do in this small limited scale. But it's very motivating to do something to improve the world. Make it fun and enjoyable in the way you present it helps. And we talked about this last time. One easy trick is to give students choice. So hopefully they can pick something that they care about. We'll see if that works with you with the lessons. And somewhat orthogonal, you can try to embed something that's just creative, that caters to other types of engagement. Or again, some people enjoy it more to make something new or make something artistic, and others not so much. Try and have a bit of everything. Not easy. Another bit that motivates people is the social context. If there's a peer group that pushes you, you are much more likely to succeed in studies and many other things. There's this famous saying, you join a company, but you quit a manager. A lot is determined by how you interact with other people, and learning is the same. So it can be a positive thing if you feel like you belong in a group and you feel this reinforcement from a learning group or from the larger cohort. It can also be a problem if you're the odd one out. The tricky bit is it might not be actual hostility by anyone. The feeling that if you feel you don't belong, the damage is already done. And it's real if you feel it. It's not about objectively measuring, is someone really making your life harder? In a way, you make it for yourself harder, but it's not to be blamed on you either. It's just a tough one. But we have ample evidence that whatever makes you feel standing out in some way can be negative, or can make this a negative experience for you, and it has an impact. So that's a tough one to solve. But one exercise I would invite you to do is think about some context where you were the odd one out. Think about how you felt in that situation, and what might have helped you at the point. So what definitely helps if you're teaching is you can try to keep a few things out of your teaching, so that at least you don't trigger these things more than necessary. Stupid jokes about stereotypes, we just don't need those. We can tell other jokes. You can, if you have to invoke personas, characters in some story, you can try to make those more diverse. Much more effective than this is having role models and having some representation of various people show that you can belong to this group. This is a tough one to solve. I think it just needs a little empathy. And in the small groups of a classroom, it's on one side easier because you can try to get into talking to individual students. On the other hand, it's much harder because they already come and bring their social context from the classes. And to be fair, it can be heartbreaking sometimes if you see certain students isolated in the group, and there's not much you can do about it in one session. But you can show empathy and make sure that at least your session doesn't contribute to that. So yeah, social motivation is a strong one, unfortunately in both ways. Another nice vocabulary, or something that I like very much, is this idea of the growth mindset. So I want to contrast these two things, and this is a way how you approach learning. And it plays into motivation. That's why in this it's coming up here. But it's also specifically about your approach to learning. It's easier to start with the fixed mindset. So the thinking is, if something goes wrong, then it's your fault and it won't change. So any mistake in some exercise is your personal failure. You can't do that. I'm not good at a certain thing. So as a consequence, it's not even worth trying. I put maths here just because this is how it's very often framed. Okay, I don't want to claim that this is still the case, but I remember that this was at least said in my school time. There's math persons and the others. The good thing is we don't have any scientific evidence for that to be true. Now, definitely people differ in how much they enjoy and approach certain topics from an intrinsic motivation. So some kids jump at math puzzles and others don't really bother and just color in the puzzle pieces. But we don't have evidence for mental capacity to have a fixed limit. If you care enough, if someone teaches you enough, you seem to be able to push it further and further until you run out of lifespan. But there's no, to my knowledge, no fixed limit, which is quite encouraging if you think about it. So if you carry a fixed mindset with you, it's only something within you. You can change it. And we can try to avoid, again, calling things up like this in teaching. Now, I should mention fixed and growth mindset is, again, it's not some personality trait that divides the population into two parts. You usually exhibit one or the other depending on a different area. So you could say, well, I was never able to be stretchy and do yoga and this thing, so I don't even try. That's fixed mindset in one thing. At the same time, the same person could say, oh, well, I'm not good at football yet, but I'll just keep practicing every afternoon and I'll improve. And if I don't know, if I never score a goal, I'll just have to practice more. So it's funny how the same things go together in one person. So the positive way to phrase this is, if you do things wrong, you just learn something from it. Not yet is the key tag phrase that people try to use this. I don't know if you've noticed this on food packaging. There's always these recycle advice. So it's locally recycled, blah, 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 or not yet recycled. A lovely feature of growth mindset, even though maybe in this case it's a little cheeky, because the hope with the growth mindset is that there's some anticipation for improvement. All right. The way you can use this in teaching is, I guess, again, the same solution, the low floor, high ceiling tasks. We have several tasks. Try to give several chances and make it clear that failing at one task is not a failure of the person. All right. Have you heard this term before? Growth mindset. I think it's more well known these days, but it's something I just want to stress. So that's the bit on motivation. Questions about this part before I move on to the learning? That part will be short. I just want to very, very briefly touch on these things to the point where we will feel their impact in the lessons. So what does it mean to learn something is actually not so clear. There's two main definitions with others that I'm leaving out. But the key main difference is you could either say learning means some person's behavior is changing, and that's in a way that I can observe from the outside. So the standard thing for that is reinforcement learning in like the old style. I'm not talking about machine learning in this case. So if you train your dog to anticipate the treat, if you ring a bell, and then you ring the bell and you see the juices collecting, then you have conditioned the dog. So you have changed the behavior. The dog obviously has learned something, even though in that case, maybe a weird association is the actual thing. Sadly, teaching often is like that. In particular, assessments often take this viewpoint. You have learning outcomes, so you start designing learning outcomes, and then you try to design how do I get my students there. To some degree, you need this, but you may potentially not want to focus on this entirely. The other part, the other end of the spectrum says learning is not something you can necessarily see from the outside. It's something inside the learner's brain. So there's some transformation going on. And there's some really lovely experiments that illustrate this concept. We're a bit late, so maybe we don't have time to watch the video. Has someone seen Piaget's experiments with children? There's one about the most famous one, I think, is a one where they show that up to a certain stage in their development, children are not really able to count. Now, you teach them counting, teach them the numbers, and they just regurgitate 1, 2, 3. So they memorize the numbers, they play it back, but they haven't internalized what the concept of a number is, of counting entities. And the way they show this in this video is really sleek. So you place objects in a row, and then you ask the kids, is there more of this or more of this? It's 2 rows, same objects, but spaced out differently. And up to a certain age, the kids will always point to the row where there's the items more spread out, even if it's fewer. And that shows they didn't count. They didn't understand that they're supposed to count how many there are. They just replaced that with a simpler question that they can understand, which is size. And then from a certain point on, magically, the coin drops and they start to count. I repeated this experiment with my youngest, who's 6 today. This was well over a year ago, and he couldn't do it. And then soon after he did. It's magic. It seems counterintuitive that there's this magic moment, and it's not something that you do from the outside. He counted before. If you told him to count, he could do it. So watch this video. There's many other examples of this. As you can imagine, it's hard to study this empirically because you have to set up really smart experiments. For this simple counting, okay, you can imagine how this might work. So I think the trouble with this is it's harder to really establish knowledge. What are the concepts that need this trigger moment? Well, what does this mean for teaching is that you can only be a guide. You can set up the environment and set up all the pieces, and then the learner has to do the rest, which can be a test for your patience as a teacher. Most of our teaching today is a combination of both, obviously. The way I'm bringing this up is if you design some activity for your lesson, you might try to do both a little bit. Many people are very motivated about some interests, who are very into some topic, tend to design things, including myself, that are heavily on the constructivist side. So you design something where the kids play around, and then they're supposed to get it. And it seems to work well with some kids, and it seems to completely lose others. So it's tempting to do exploratory activities only. And I'm listing this because it's exactly what I did. And again, it was a bit heartbreaking for me to see that for some kids it works so well and for others not at all. They were just not clear what to do. Now, okay, I can say that's the fault of the teachers who know they spoon-fed them up to here and now they can't explore anymore on their own. Even if that were true, like what point is it? That's still the case. And probably it's not quite fair. If you think about how you, I hope that you all have something in mind where you understood some concept by playing around in one way or another. If you're fair with yourself, you probably didn't start playing completely in the open. You had some things that build up to that. And if you take that out of your activity, it will fail for those kids who didn't already do these steps. So a way out of this is scaffolding. You give some partial steps and you leave just some parts to fill in for the kids freely. Another option is after the fact, tell them what they could have observed without blaming them if they didn't. Does that make sense? It might become more concrete if you're thinking about specific lessons or specific activities, rather. The last bit is a very vague one. So there's this cognitive load theory that says our working memory is limited in some way. So if you're just told to memorize digits or something, it's often 7 that for the average person is the limit, unless you start to play memory tricks. The interesting bit is we speak of 7 chunks because what this individual thing is not so limited. It can be 7 really abstract and big and complicated topics. If you have internalized them enough, it counts as 1 chunk. So the theory behind it is you have some things already connected up. If you have, then they only take up a single chunk in your working memory. And so you have more space left for the task. So there's parts that come from the task that are inevitable, and then there's usually something else on top because you're teaching it in one way or another. The goal, of course, is to reduce this, but that's in this abstract setting fairly useless. But what helps is to point out connections of topics so that things are not unconnected dots that you have to keep all in your working memory at the same time, but to first connect them into 1 chunk. I think that's one big reason why people try to have terminology, why you try to coin specific terms for things, is that helps you to chunk them up under this term. This one's hard to do for our sessions because we're basically given what the students come with. This is more useful if you're designing a longer curriculum. Then you can try to build things up and not throw too many things on the pile at the same time. We only have limited capacity to do that. The last one is Bloom's taxonomy. I think this is probably another very well-known one. Have you seen this? Okay, some haven't. In essence, it's a way of saying how deeply do you engage or understand something. Understand is not a great term. So it's the original one has many more levels, but I agree with the ACM, with the Computer Science Association, that for me there's really 3 distinct levels that make a lot of sense to me. And maybe let's go through these just to make it more concrete. So the most basic level of mastery, of how much you mastered a topic, I think that's really the nicest way to put it, is familiarity. So you've memorized the definition, you've seen it before, so you're aware that these things exist, and you can ask questions about what do you know about this. In a way, it's reproduction. So it's taking things you've seen before and you can reproduce them in your own words, maybe, but it's not much deeper than that. Usage goes beyond that, so you can apply some concept in some concrete but new way. So it's not something that you've seen in exactly this way before, but you can use some template on a new example. So it's about what can you do, or what do you know how to do. Say in an algorithms class, this could be knowing some basic performance of some algorithm, which you've covered in class, so you just write that down. This could be apply an algorithm on an example, so you can demonstrate that you know how it works, which is more than just memorizing the code. You have to apply it. And then assessment is the last level of this, which is comparing different things and comparing their quality in an informed way. So it's you're given just a task, and you have to come up with the algorithm to solve it. And so, I mean, usually the idea is not that you just shoot down some algorithm, but you justify why that is a good choice. I think mostly these are to balance out assessments. So for your lesson, maybe it's not that relevant to think about, but it's useful to keep in mind that these are 3 different levels that you usually go through in succession. You can't really use something if you're not familiar with it, and you can't assess it if you're not able to understand how it works. So the main use is for tasks assessments to say at what level do they shoot, and ideally you want to balance this out in your teaching. All 3 are important and relevant. Sometimes forgotten. Again, if you're super excited about something, you tend to focus, let's just do the assessment, all the other, that's boring, anyone can do it. But that's a mistake usually. All right, and any questions about these learning theories? Did it make sense? It's a backdrop, really. So don't feel like pressured to squeeze as much of this into your lesson by force and modify your idea so long until everything pops up in it. But take each of these theories, look at your lesson, and think about if there's something where your plan would contradict that theory, would I don't know, exclude some kids, play against the social dynamics, instill a fixed mindset. Any of these is essentially a check that you haven't done any obvious things, a due diligence task.